Okay. Lab test 1 is coming, right? Not this Thursday, next Thursday. So it'll be next Thursday and the Tuesday after that. As I promised, I'll give you some preparation guide. I'll distribute a guide on Thursday. But there will be some preparation you can do before Thursday. So if you go to the lectures page, as usual, you can see that in the background slides over there, there's something called loops. So I presume you learned about arrays back in 1022, right? Arrays, simple arrays. I would like you to review the relevant parts in this slide here about array, just how you can get indexing into the array, and how you can write some simple loops about the array. So I'll give you sample exercises on Thursday. I'll give you maybe a bunch, maybe about 10 up to 20. I encourage you guys to work in groups and try out all the examples. And all the examples are going to be about utility methods. And the input to the utility methods will be maybe an array, or it can be, for example, it can be an array of integers, and I want you to return the maximum number in the array. That's one example. Or I can just give you integer, and calculate the average, something like that. There'll be some easy exercises, there'll be difficult ones for you to try. So that can more or less prepare you very well for the lab test next Thursday. Okay, I'll give you the guide on Thursday. Okay. So today I would like to finish JUnit test. Okay, let's just go back to JUnits and then let's review very quickly about the setup. And then we'll go to the lecture, the new stuff. Okay. Okay, let's review the problem that we are trying to solve over here. It's a very simple utility classes, has only three attributes, 2 constants and 1 variable attributes, which is value. It should be between the minimum and the maximum. As you can see, oh, by the way, something I forgot to mention. If you go to the website over here, you can see I put a sample, some new source code over here. I said a solution to the exercise counter. Remember the last slide I presented last Thursday? So that's the exercise you were supposed to complete. So if you haven't done that, don't look at the solution just yet. Try that yourself and then compare with the solution. Look at that. If you got any questions, you can ask me during the office hour or send me an email. Okay? Okay, so this is the utility class we are trying to eventually test to see how correct it is. So now there will be a certain constraint we have to pay attention to. So the only requirements we have to pay attention to is the counter should always be in between the minimum and the maximum. Okay? Whenever you try to change the counter value, you have to make sure this particular requirements is respected. Okay? That's something we want to make sure. And because we have certain constraints, so there will be preconditions for updating the value. So there are 2 kinds of preconditions there. Either when you're trying to increment the value, when you're trying to decrement the value. Okay? So for example, when you're trying to increment the value by saying plus plus, in that case, you better not be too large, the value. Otherwise, you will have to go above the maximum bound, which is not allowed. Okay? So we got 2 kinds of violations, and we talked about them last time. Okay? So let me just go on. And I think that's where we should be today. Okay? Any questions just about preconditions and how you specify them? Okay? I would say for this, as far as this course is concerned, usually the preconditions you have to write, they're rather simple. All you gotta really make sure, for example, you can see that over here, the precondition violation condition here is to say if the value is equal to the maximum value already, then you cannot do increments, right? So let me review this very quickly for you. So you should be able to justify to say, if I give you another alternative, you should really justify to see if they are really equally good or they are worse. Let's say for increments. Over here, let's say we have integer value. Okay, let's say this. And we're gonna say if certain condition over here, I'm going to throw that illegal argument exception. Otherwise, I'm going to do the increments, the counter plus plus. I'm going to run the bunch and then to see which one might be okay, which one may not be okay. What if I say counter, the current value is larger than the maximum? 1, and the counter is less than or equal to the maximum, or the counter is greater than or equal to the maximum. Look at these three options over here. Of course, some of them may be correct, some of them may not be. So may not be in the lab test, but I could. There might be some short answer question in the lab test or in the final exam. I might just give you these three alternatives. First of all, I will ask you to tell me which ones are not good. But how do you justify some preconditions that are not good? You gotta give me a witness, which means you gotta tell me a problematic scenario which will be allowed for this kind of precondition, right? Okay. What about the first one? If I say I will only throw the precondition violation if the counter is larger than maximum, is this good or bad? Bad, okay, I agree. So now can anybody justify to me why it is bad?
Let's say it's at maximum. Say only throw it 3. You're going to add 1.
Okay, very good. So let me just rephrase that. So first of all, number one is bad. I'll just put a cross mark. Why? Because if the counter value, if it is currently just equal to maximum, in that case, you have maximum larger than maximum, right? You have both sides being maximum. In that case, that will give you simply just false, which means the exception will not be thrown, right? So which means the supplier is not careful enough. In this case, that means you will just allow, in this case, for the increment to happen. Okay, that's why this is not good. What about number 2? Number 2. Number 2 somehow, well, first of all, good or bad? Bad, okay. So would you like to justify? Please.
Well,
let's say, well, first of all, I can tell you there are more than one way to justify it is bad. I will do one for you already, okay?
Well,
if the counter is equal to maximum, then we don't want that, right? Okay. Anyway, just say whatever you like to say.
so let's say that the max is 3, and right now you're at 1. It's going to throw the exception even though you did not hit max. So you still can go to 2 and then 3, but it's just going to throw it right away.
Exactly.
It's less than the maximum.
Somehow you're being too restrictive, right? Okay, very good. That's not cool, exactly. Okay, number 2 over here, I'm going to put it here. Number 2 also is not good. Actually, number 2 is even worse. That means you are forbidding all the valid value you should have allowed, right? For example, let's say, if the counter currently is equal to, let's say, just 1. In this case, if it is equal to 1, from your intuition, this should be allowed because 1 incremented by 1 would be 2, which is still valid. However, according to this current precondition over here, 1 less than or equal to maximum is true, which means we will throw the exception, which is not good. That means it is not allowed. Okay, so when counter is equal to 1, and then we have 1 less than or equal to 3, and that will give you true. So that means exception is thrown. Okay, that's how you justify. That's why number 2 is not good. What about number 3? Number 3. Counter larger than or equal to maximum. Yes. Well, I only said which ones are bad. It could be all of them are bad, right? Could be. You don't think the third one is bad? Anybody disagree? Yes, yes. So yeah, so be careful. So a bad precondition might work sometimes, but as long as there's at least one case that doesn't work, then that's not good. Okay? So this one also is not good for the same reason as 1. So number 3 over there, also not good. I would say same reason for 1. Same reason as 1. So hopefully that gives you a flavor about playing with the preconditions. But when you get to 3311, you actually get more practice. But for this course, I just want you to get a flavor about what preconditions are about. Okay? Any questions about this? Huh? 3, well, 3 over there. Oh, wait. I'm so sorry. So Raymond, I was making the same mistake as you did. I just thought about it wrong. Guys, you should have told me earlier, right? Yeah, exactly. Next time, if you sense that I'm saying something that doesn't make sense, stop me right away. Okay? So I'm gonna say no over here. Number 3, okay. So it's a little bit tricky. Okay, let me try to demystify number 3 again. Okay, how about we thinking this way? For number 3 specifically, why it is okay? Oh, sorry, undo. Good. Over here, there's another way to justify it is good. Another way. Why? You can see that number 3 condition is under the if. Remember what you learned from the first year. If you have some Boolean condition in the if, the else part should be the logical negation of that, right? So over here, for number 3, you have counter larger than or equal to max. And that means you can only increment if counter is strictly smaller than max. In this case, the maximum value you can actually still do increments is maximum minus 1. In this case, you can still plus 1. That will just bring you to the maximum. Okay? That's why number 3 is absolutely fine. Okay, be careful. Thank you. Very good. Yes?
Can you explain again why number 1 is false?
Of course, no problem. For number 1 over there, number 1 is counter larger than max. Okay, let's think a little bit differently. Okay, so now if the condition over here for the if is counter larger than maximum, what does it mean for the else condition? That's counter less than or equal to max. Agree? Okay. Guys, please. Okay, so I'm going to write it here for number 1 over here. So that means the else condition for that is simply counter less than or equal to max. Oh, sorry. Less than or equal to max, right? So now that means you can still do the increments when the counter is equal to max. Is that good or bad? That's bad, because that will give you maximum plus 1. So that's why it is bad. You allow something that will make you go above the maximum. That's why it is bad. Yeah. Does that answer your question, maybe? Good. Yes?
Why can't you increment it when it's equal to maximum?
Because that will actually make it maximum plus 1. Remember, we got the requirements saying that it should be between minimum and maximum. Yeah, that's why. Yeah, always remember, there's got to be certain requirements you're programming against. So in this case, as I said before, it's a reminder. So you actually just have these requirements over here. It should be between lower and upper. That's why. Okay. If no question, I will go on. Okay, for simple counter, we got these 2 methods, increment and decrement. Okay, so now let's see how we can test. So now we got 3 attributes. We have 2 methods. It's a very simple class. How do we test this class? So let me just give you some idea how you may test without JUnits. I claim that maybe the best you can do is to maybe try different cases and try to run maybe it's like a console application to say, I would like to maybe do this particular updates to the counter value, and I expect it to be maybe 2. And then I will compare with the output to the console and to see if that's really 2. Okay, I'll illustrate to you what I really mean. And let me show you some slides first, and then I will run the Eclipse with you. Okay, the source code is also available. I can also illustrate to you. Let's say we are trying to define a counter tester. Okay, that's counter tester number 1. Depending on how many cases you would like to test, you got to create that many counter testers. So we got a main method here. Let's say here we simply say we print out to say the initial value of the counter, and that should be 0. Sorry, it should be 0. The minimum should be 0. And now we say that we are trying to decrements, and we really call decrements over here, right? So that's a very simple case to test in the console. So now, let's say you're running this test. What do you expect to happen? Exception, right? Because there's a precondition violation. The value for the counter is simply the minimum, and you're trying to decrement, so the expected behavior should be a precondition violation. Agree, everybody? So now, that's what we think in paper. But how do you verify that in the machine? Well, I will just tell what you should do, and then I will illustrate to you. What you should do is you got to right-click on this class and say run as Java application, and see what's really output to the console. Compare that with your eyes, and then to convince yourself that's really the case. Okay, let's have some idea what you would do. I'll only do one. Okay, so if you want to try the source code, I'll show you. You can also, if you go to the website, you can see that we got something called testing utility classes. Okay, so I already got it on my desktop, so I'm going to import that to my Eclipse. So what I would do is I'll create a workspace on the desktop for today from scratch, and then I will launch Eclipse. The reason that I really want to show you how you can run, I want to illustrate how bad it is. Okay? Okay, so we got workspace on the desktop, and now we'll launch, and now import the projects, and now I'll show you how to run it. And always, when you're doing certain things, think about what's going to happen if my software project is very huge. Is this method is going to scale? It's going to apply even to large software projects. Okay, that's the question you should keep asking yourself. Okay, so I'm going to import. So file, import, and then I'm going to import some existing projects. So I'll click on that, and next. And I want to select an archive file. Browse, and then go to desktop, and then choose testing utility classes. Okay, I'll do that. And there's only one project there. I'm going to say finish. Okay, it's already there. Okay, so now again, if you look at that project there are three clusters. Again, we said that we use, not cluster, packages. There are three packages over here. Each package is going to group relevant classes. So now we actually have the implementation. At the moment, we only got the counter class, which we just explained. And under console testers, I call them console tester because you have to know the result by comparing with your eyes on the console. Let's say console test number 1. Okay, so that one is exactly what I have shown in the slides. Okay, I think I would just for now I'll just make the font a little bit bigger. Okay, so maybe under Java and that. I'll make it maybe just 14. I think that'll do. Okay, so now that's the class. Okay, let's see. As you predicted, it should be an illegal argument exception. I agree with you, but we cannot really believe in ourselves until we see that, right? So why don't we right-click on that class, run as Java application. If you do that, over there, you can see that from the console, it tells you you got some illegal argument exception, right? So now we're convinced for this particular test, it is a success because the expected precondition violation was thrown. Okay, any question about this? Okay, that's only one single test case. If you go back to the slides, let's go back to the slides. Let's see. Let me just see that again. So that's test case number 1. Let's just see one more, just on the slides. Let's say for this one here, we are trying to test a different scenario. We got counter tester number 2. Let's say we got this. We increment the counter 1, 2, 3 3 times. You know what? And also the reason that we actually started a new class was because the counter value can start fresh. Okay? You started with just 0. Increment to 1, increment to 2, increment to 3. And then print out some value there, and then we say the counter value dot increments. Now what do we expect to see? Exception, right? Again, how do you know? You gotta run manually again. So now, before I tell you why this kind of approach to testing your counter class is really bad, let's think about how many test cases do you really need in total. Here, I'm only showing you 2. But let's think about how you can test your software. Okay? So now the question to you, do you think test number 1 and 2 are really sufficient? Let's say they all pass. I look at the console with my eyes. I'm convinced these 2 test cases pass. Do you think that's sufficient for me to claim my counter class is correct? No, right? Okay, very good. So now, we got to think about how many do you need then? How many? I can tell you in theory and also in practice. Okay? Now, and let me draw some diagram to you. So, because it will be useful for coming up with test cases for other example. Okay? So let me just illustrate that to you. Let me just add a new page. How many of you are taking 2001? Okay, but you guys haven't talked about DFA, deterministic finite automata, right? You only talk about Turing machine. Well, a little bit similar, I would say, but it's kind of maybe less complicated than Turing machine. So in computer science, there's a notion called state machine, which is extremely helpful if you want to analyze the behavior of your software. Okay? In this case, without really telling you what a state machine really is, let me just draw that, and it will just make natural sense. So first of all, let's talk about what is a states. That's a critical word. You will see this word states all the time in your major. State simply means, in our case, it simply means the value of attributes. In our case, how many attributes do we have? We got 3, right? We have 2 constants which never change. We also got the counter attribute which might change all the time. So now, how many possible values do you have for that counter attributes? How many? I heard 3. Really? 2 to the power 3. Oh, that's too much. Well, think about what's the minimum, what's the maximum, right? The minimum is 0. Maximum is 3. How many do you have? 4. Okay. Good. I'm going to draw state as circle. 1, 2, 3, and 4. I got 4 states. Okay. And then, now, the initial value is when the counter, I'll say C, is simply equal to 0. And the maximum is when C is equal to 3. That's the maximum. Agree? And I also got 2 possible values in between. So I also have C can be equal to 1, C can be equal to 2. Okay? So these are the circles. Circles represent states, which are the possible value for your attributes. You might be wondering, what if I have 2 attributes? Good questions. If you have 2 attributes, that means you have to consider all the combination of their values. Okay? So now, initially, we know that the initial value for C will be just 0. So I just draw an arrow like this. So that means I start with that. You'll learn all about this when you talk about DFA in 2001. So maybe a nice preview. So Jeff should be happy about it. I talk about DFA first to prepare you guys. Okay, so now here we got different states, but now there are no connections between them. How can we connect them? We use something called transitions. So every time can you make a transition between one state to another, in our context, is by calling a mutator method. Okay? Transitions are mutator method call. Okay? So now, for example, how do you move from 0 to 1? You will do it in increments. I will say INC for increments. How do you go from 1 to 0? Well, decrements. Right? You kind of see the idea. We can go increment here. We can go increment here. And we can go decrement here. And we can go decrement here. So far, so good. Have I covered all the possible transitions in this case, in my diagram? Have I missed anything? Sorry, say it again. That's a good question. Can I have a transition from 0 to 2? Can I? That's the question. Can I do that? The answer is no. because there are only two methods that we have defined, which is to increment plus plus or decrement minus minus. So no. Okay, that's not an issue. Yes. Aha, it's also possible, right? There might be an attempt, exactly. So we're missing two transitions. Maybe you can try to do increments when you are 3. You maybe do decrements when you are 0, right? It's possible. Now, so which state should it go to? Let's say we are in state number 3. I mean the last state, the rightmost state over there. Where should I go? I cannot just go back to 0 wrap around. That's not the way to go, right? Well, there's a particular state that's called the dead state. I'm going to put it here, dead. I didn't make it up. It's really called that, dead states, which means once you reach that state, you're done. Game over. Okay. Okay, let's try that. So now if you are in C is equal to 3, you can do increments, or when it is 0, you can do decrements. Okay, so now you can see that we got increment, decrement, we got 1, 2, 3, 4. We got 4 times 2. We got 8 different arrows. Does that mean in theory we only need 8 cases to cover? Well, let me give you a hint. So now, let me ask you, in theory, how many test cases do I really need in order to cover this state machine? Or let me phrase it another way. Okay, I'll write it down. I'll write in different color here. So let's say how many test cases? Alternatively, you can think of how many paths. I'll illustrate to you what do I mean by path. Path over here. So one path can be, I'll use the blue. This is 1, this is 1. So that's one path, which means I go from 0 to 1, 1 to 2. That's one possible path. Another possible path is I might go, let's say, increments, 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 and decrements. That's path number 2. How many tests you really need in theory correspond to how many paths you can reach from the initial states. How many do I have? How many? I need a number. I heard 8. I heard 8. No, more than 8. You got way more than 8. Huh? 2 to the power 4. 4 to the power 4, even larger. Even larger. Factorial, even larger.
Even larger?
Even larger. Infinity. That's the number I'm looking for. Infinity. In theory. Infinity. Why? Let me tell you. It's very easy to see why it is infinity. Let me use another different color. Let's say yellow. Let's say I can have one path that goes like this. I go from 0 to 1. Oh, sorry. I want to highlight. I can go from 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, and go as many times as I like until I lose my interest, right? So you can see that easily. If you just want to talk about how many paths can you have, infinite. That's in theory. In practice, of course, you wouldn't do infinity. You don't have the resources, you don't have the time. You just gotta make your summation, right? In this case, what should we do? So so I wouldn't address too much about what kind of testing strategy you should really have, because this fourth year level course called software engineering testing. If you're interested in software testing, you can go for that course. It's actually quite fun. Okay? They also I think they also use JUnits over there. But now for here, one particular strategy is simply to cover the number of arrows you have. Okay? Just call it, you can call it transition coverage or something like that. Okay? So now, as I said before, how many arrows do we have? 8. So 8 test cases, as far as we are concerned, is good enough. Because if you cover 8 arrows, in this case, you basically have covered all the possible values of your attributes, and also all the possible, reasonably sufficient ways to really reach those values if you cover 8. Okay, any question about this example over here? I would say this example is not that easy to draw the diagram, but hopefully that's clear enough. So I would say later on, not just for this course, if you try to come up with test cases for your software, I think drawing some state diagram would be a very promising start, okay? Especially when you're learning in 2001. A very practical application for drawing state machine is how to come up with test cases, okay? Okay, let's go back to the slides over there. So now we agree that there should be 8. So that's just another, it's like a tabular form for the test cases. For each possible value for the counter 0, 1, 2, or 3, you can try to do increments or decrements, right? So now I will draw your attention to 2 things over here. Let's compare this cell over here. Okay, over here, you can see if the counter value is currently 2, and I'm trying to do increments, you can see this means the test will be considered as a success if the resulting value for the counter has become 3, and no input, no precondition violation occurs. That's what it means to be success. On the other hand, if you look at this cell over here, it's kind of the opposite. In this case, when the counter value is currently 3, and we are trying to do the increment, the same operation, the same method. However, in this case, we consider that as a success if there is a precondition violation. You see the flip, right? So now you should really try to convince yourself what we consider as a success over here is no precondition violation. On the other hand, for this case over here, we consider it as a failure if there's no precondition violation. Okay? That's something I want you to pay attention to. And these 2 categories of doing tests can easily be done in JUnits. But if you want to do it in the conventional way, like in console, you have to, again, use your eyes to compare the values on the console, right? Okay. So now, let's say we don't have JUnits. We already got 2 counter testers. So now what should we do? We're going to create another 6, right? And now let's say now I say, okay, you're done with the 8 test cases. Now run them. You got to right-click on the number. You got to right-click the first one, right-click the second one, right-click the third one, and then compare each one of them. And you tell me, okay, now it's fine. 2 hours later, I say, do it again. You got to right-click on the first one, right-click on the second one, right-click on the third one, and do it again. You said, done. I'll say, okay, do it again 1 hour later. Right? You can see kind of, that might just be so common because when you are developing your software projects, you might just have to change your software very often. Every time when you're trying to introduce a change to your software, either because you're fixing a bug or you're just adding a new functionality, what you really don't want to happen is all the test cases that used to pass now fail. That's something you don't really want, right? But now, every time when you want to rerun all the test cases, you don't want to just manually repeat them. It's very tedious, and you might just make some mistake. Maybe right-click on the wrong classes, right? So what we really want is we want some automation. We want the automation to say once you have accumulated a list of test cases, every time if you want to run them, you can just click a button. And then Eclipse can just tell you, yes, we have passed all the test cases. Or to tell you, no, you have failed at least one. Okay, either green or red. Okay? So that's something maybe you have seen already, but now I'm just introducing that to you formally. Okay, why JUnits? Why JUnits? Of course, we want to somehow automate the testing of correctness. Let me just say one more thing over here. Let me just say, so there are 2 notions of criteria to judge whether your program is good or bad. So there are 2 notions. Let me say criteria for judging your program. There are 2 notions. Number 1, correctness. Number 2, efficiency. Correctness means whether your program does what it is supposed to do. Okay? Efficiency means whether your program runs fast enough. So now, let me give you, again, 2 options. Okay? Option A and option B. Option A, let's say some program that is correct, but it is not efficient. You learned about 1090, hopefully you're okay with this notation, right? Option B, not correct, however, very fast. Would you, well, let's say you are a client. Which one would you prefer? First one, right? But if I'm a supplier, I'll prefer number 2, right? How do I do that? Let's say you are the client, I'm the supplier. You said to me, Jackie, now I give you an array of 1,000,000 integers, sort them into ascending order. I said, sure, I can just give you right away. I just print out hello world. It doesn't do anything useful, but it's very fast. Okay, I'm kind of giving you some extreme cases, but of course, number 1 is, of course, the option A is really the best. Okay, you should really aim for that. Okay, so now I would say you may worry about efficiency once you get into 2011, but we will talk about some kind of efficiency in this course as well, some preliminary introduction. But you will only worry about efficiency once you are pretty sure your program is correct. If your program is not correct, it doesn't matter anymore. Doesn't matter. Okay. So now, let's talk about correctness over here. So for correctness over here, it's really difficult to talk about absolute correctness, because if you want to do some very confident and very thorough certification of your program, what's the best way you can do? Well, you got to follow what you learned from 1090 and do a mathematical proof of your program. But we don't want to do that. We don't have the resources to do that. Okay? It's too labor intensive. So instead, what we do, and what people usually do in the software industry, is we actually have to define a reasonably complete set of tests. That's the best you can do. So how confident you can claim that your program is correct really depends on the quality of your test cases. Let's say if you tell me that your test cases only cover the 2 scenarios we first talked about, then that's not very good. On the other hand, if you tell me that your test cases cover all the errors in the diagram, in that case, of course, it's good enough, right? So again, that's really about how well you have developed your test cases. Okay, just about some background knowledge over there. Okay, good. So now, let's talk about JUnit very quickly. I'll just go over some concept over there, and then I'll do some coding with you. And there are 2 kinds of JUnit tests. Both you should really try to master both. Okay. So now we talk about clients. We talk about supplier. Okay. Let me just go over this slide very quickly, and I'll draw some diagram to help you understand. We can think about JUnit tests. They are somehow users or clients of our code. So they are simply going to call the methods that we define. Okay. Utility methods for now. So we'll say that, so now there are 2 possible ways that JUnits may try to use our code. Either they try to use our code in a legal way, which means no preconditions are expected, no precondition violations are expected, right? That's way number 1. So they're trying to use a legal way. And then now, if they try a certain test, for example, you're trying to increment the value when it is 1. In this case, no precondition violation are expected. And what we need to do is compare the resulting value by doing the increments. That will go from 1 to 2, right? So we're going to compare the final value. If that's really 2, then it's a success. Otherwise, it's a failure. That's category number 1. The second category is when we are trying to use the program in an illegal way. Let's say this. Let's say the JUnits should also try to use your program. Let's say they try to increment when the value is already at the maximum. In that case, what we should really expect to see is not any expecting value. We want to see some precondition violation, right? So in that case, it will be considered a success if the precondition violation occurs. Otherwise, it's failure. Okay, so these are the 2 categories, and we should know how to use both of them. Okay, I'll demonstrate to you. Okay, so now there are some screenshots in your slides, but I'll rather just go to JUnits and show you. Okay, let's see how we can do that. So I'm just going to build another class in the project that I just imported. and then I'll do everything from scratch. Okay? Let me just draw one more diagram before I go to Eclipse. Okay, over here, let's say we have, first of all, so let's say we have the class counter. Okay, so somewhere we have the method increments by some value. Okay, you have some implementation over here. So this is the supplier code. On the other hand, we have the client's code. I'm going to say over here, clients. And in this case, the client is kind of special. The client is very helpful. They are very constructive. They are trying to help you. So in this case, they are JUnits. JUnit class, I would say. Okay, let's just define. JUnit class is basically just another Java class. You say class, and then you can say test counter. Over here. And there will be some special import statement which you don't have to worry. Eclipse will do that for you automatically. I'll show you how you can do that. But let's say we have a test counter class. Now, basically you're going to define every scenario as a method in this test class. However, there's one special thing you have to pay attention to. Okay? Maybe you noticed that already in your lab 1, which is now, before I try to translate my test scenario into a method, I have to put a special tag, test. And that's case sensitive. It's gotta be uppercase, okay, T-E-S-T. So this means whatever that follows this tag here is going to be treated as a test case, okay? And then let's write something very quickly. And then usually it would just be a void. It's just a mutator. And the convention is you will start the method name with a lowercase test. You can say test, I would say increments. Let's say test increments over here. And what do you do in the method? Don't think that's too complicated. Basically, you're just trying to use the counter class, use its method in a particular way. So now let's say what I want to do is, I want to start with the initial value 0, and I want to increment it just once. Okay? So what I can do is, I know that, let's say, counter dot increments. Okay, we know that before this point, it was 0. After this point, it should be 1. And there's no expected precondition violation. If there was, then that should be considered as a failure. Okay? So now, we want to somehow write something over here to check the resulting value for the counter after the first increments is really 1. Otherwise, it's a failure. Okay? How do we do that? So for JUnit, they support something called assertions for you to use. So I'm going to introduce one of them to you. So there are many of them you can use. You can see the slides. So I'm going to write in red over here. It is something called assert true. And then you're going to have something over here. Whatever that goes in between the parentheses has to be a Boolean expression, which means it's going to be some expression which will evaluate to either true or false. In case it is true, you pass the assertion. If it is false, there's going to be some assertion failure, which will also make the whole test method fail. Okay? So now in this case, I really expect the counter value at this point to be 1. So the Boolean expression I can put is, I can say counter dot, let's say value equals 1. That's what I can do, right? That's what we have. There's a very simple test case. Any questions about it? Of course, you can do all the, there are others, most of the test cases for the counter are like this. There will be another category. Let's say we try to do decrements right away. In that case, we are really expecting some exception to be thrown. In that case, it will be done slightly differently. Okay? But now I would like to show you this first category first. Okay? And then I'll show you the second category. The second category is slightly more complicated. Okay? So now let's see the first category. And let me go back to Eclipse and show you. Sorry, I don't mean to open that. Okay, so now let's go to Eclipse over here. So now you will see that there's a package called tests. I already got test counter. I'm just create another one. How do you create a JUnit test? Right-click on the package that you would like to create a test into. Right-click, and then you will say new. Sorry, go a little bit too far. Go to new. Usually you would say new class, but now you say new JUnit test case. Okay, that's the difference. New JUnit test case. And now make sure you choose JUnit number 4. Okay, that's the version we're using, not the old version. And then you got to give a name. So you can say test counter. That wouldn't be allowed because I already got test counter. Let's say test counter 2. There are certain other methods over here which we don't have to worry for this course. But if you're really interested, you can feel free to Google them. You can see the explanation for them. But we don't, for this course, we don't need to worry. And then we say finish. Okay, so now let me maximize this. You can see that we got test counter number 2. Okay, and then you can see they already gave me one test, or just one. Okay, and now you can see that we have a test tag over here. And you can see this fail assertion here is very interesting. What does that mean? That means it fell no matter what, just fell. Okay, so let's try to run this test case right away and see what's going to happen. If you want to run a JUnit test, right-click on that and say Run as JUnit test. Run as JUnit test. If you do that, it would trivially fail. Okay? Don't be too terrified by the failure trace over here. Sometimes it can be your friend. Okay? You can see that it simply tells you got some assertion error. Where was that? If you double-click on the next line, it tells you it was exactly this line that caused the trouble. Okay? Now, remember what I said before. In this kind of case, since we are trying to say if there is some error, we're going to cause some assertion error. How can I make this test case pass immediately, trivially? I just comment this out. Which means this test does something. What does it do? It does nothing. Which means nothing wrong is going to happen. Which means it will succeed. Okay? Let's verify that. So now I can just rerun the JUnit test. You will see that green bar. However, don't get this illusion that we got correct software, right? Getting a green bar doesn't mean too much, to be honest. It really depends on the quality of your test cases. Okay, let's do something more useful. Okay. Now let's say I want to do test 1. Let's say test 1 increments. Just 1 increments, just as an illustration. So now so for each test case, you can have more than one assertion you can try. So I would say the principle is try to group the relevant assertion into a single method. Okay? There's only one principle, but of course it's subject to your practice. Principle is group relevant assertions into a single test method. Okay? That's the kind of the principle. Now let's try. Test 1 increments. This is a test case where we increments the counter once and see if the actual value becomes 1. That's basically what we're trying to test. So now what we can do is we can say counter dot value, increments. Increments, and then after this, I simply just want to make sure that the value really has become 1. I can say assert true. And then I can pass some Boolean condition. I can say counter dot value equals 1. Okay, that's one test case. Make sense? If you like, you can also say before I try to do the increments, it was really 0. I can say assert true. Counter dot value equals 0. Like that. Okay? Yes, thank you. Yes. So I got 2 assertions there. Any one of them fell, that means my test case fell. Okay, let's try this. I can just run again. Okay, green bar. It does slightly better. Okay, now, what does it really mean when you're trying to compare the expected value, which is 1? However, the actual value is not really 1. That means you got a failure. Let me illustrate to you what that means. Let's now change the supplier intentionally to be wrong. Okay? Let's go back to the counter class, which is the supplier. Since we are trying to test increments, let's say this. Let's say somehow this particular supplier is crazy. They say plus equal 2. Okay? Like that. Because all the implementation details are hidden from us, so we don't know. That's why we need to test. Okay? Now, if I go back to this particular test, the test itself makes sense. After increments from 0, you should get 1. But now, what will this give to us? You would say 2 rather than 1. 2 and 1 don't match. So you will get an assertion failure. Let's double check with that. So which assertion would fail? Line number 17 or 19? 19, exactly. 17 is still okay, but 19 was the trouble. Okay? Why don't we try? Okay, right? Now, if you look at the assertion failure, it tells you that it was this line that was causing the trouble. Okay? Once I finish talking about both categories, I would like to show you one very important tool in Eclipse. It's called debugging tool. Right? I will show you guys in just a moment. Okay? But now you can see for this first category, we have seen two kinds of tests, right? Either the implementation was correct, so the expected value matched the actual value. So it's a green bar, it's a success. Otherwise, if the implementation happens to be wrong, which we did just intentionally, just for the illustration, in that case, it's going to fail the test over here. It's going to fail. Okay, that's kind of the first category. Okay, let me change the implementation back to its original look, and then I want to show you the second category. So the second category is a little bit tricky. So let me draw the concept to you first, okay? And then we will talk about how you can do that in Eclipse. It's a little bit mind-twisting, a little bit, because in this case, you are expecting some precondition violation to occur, okay? Let me just go to my iPad and I'll show it to you on the notes first. And then we'll see how you can do that in Eclipse. Okay, let me add a new page. And then we'll see how this one will do. Okay, so now let's say we just got, I'll just write a test method, okay? So let's say now we want to test. We want to test an abnormal use of the class, let's say, for which we expect a precondition violation to occur. Okay, that's kind of big idea. But how do we do that? Let's go step by step. Let's say we define a new class, new method in the same class. Don't forget, you got to say add test. And then I'm going to say void, let's call this test decrements from 0. Okay? Somehow you should really make your name as meaningful as possible. Okay? And then we're going to write something here. The first try, if I do counter dot decrements, before that you can simply make some assertion to say the counter, let me make some comments. Initial value is 0 before that. And now over here we can say expect exception. Because we're trying to do decrement when the value is actually 0. It's too small. Okay. Now, this test case is the most naive, maybe your first try, because we simply try to use the method in a very abnormal way, and we expect a precondition violation to occur. If we simply run this in JUnits, would it be considered as a success or failure? Success or failure? I think we should be okay, right? What did it say? I didn't see that. Okay, it should be okay, right? Scary. Oh, okay. Well, it's a good idea to see it. Good. Okay, so now let's try that in Eclipse. Okay, how do we do that? So let's try that right away. Let's go to test counter number 2 over here. And don't forget to put the test over here. Public. Okay, so we got public and void test decrement from 0. Let's say that. Okay, I just wouldn't mention the comment anymore. You got that in your notes. Counter dot decrements. Just that. Decrements. Yeah. Just that. Now, what's going to happen here? Well, of course, counter dot decrement is going to throw that illegal argument exception, right? However, is this throwing of the illegal argument exception make this test as a success or failure? That's our question, right? Let's try. Did I do something wrong? Let me just try again. Sometimes when you write a test case, it could be that you got so many classes in your project that has main method or JUnit test. Make sure you run the right one. Right click, and then you say run as JUnit test. Is it success? Oh, decrements. Did I do something wrong? Please let me know.
No, I just have a question. Don't you have to compare it before I can tell you if it's right or wrong?
Say that again.
Like, don't you have to call it a search method for it to tell you if it's right or wrong?
True. However, in this case, because it's a little bit different, yeah, I think I know what the issue is, but let me just answer your question first. In this case, it's slightly different. What we did before, we tried, let's say we try to increment from 1 to 2. In that case, we're trying to assert the new value is actually 2. That's what we did before. But now, there is no such a thing to assert. There was an exception.
Okay.
Yeah, there was no such assertion supported by JUnits. Okay, so now what should we do? Okay. Now, let me just go back. I think I know what the issue is. Let me just go back over here. Let me just run this in isolation, and then I will do the fix in just a moment. Okay. Okay, actually that one is fine. Okay, so that's one thing to note about testing utility classes. Remember, there's only one instance for the utility class, right? We say there's only one box. Okay, so I wouldn't show you the diagram, but you remember there was one diagram. Let me tell you what the issue was. Let me first of all try to say counter the value was back to the initial value, which is counter dot minimum value over here. Okay, and then if I run the JUnit test again, I got failure. Okay, but let me explain why it is necessary. Okay, I'll explain to you. And this kind of happens for utility classes. Okay, I will tell you why. Okay. Let me just go back to the iPad notes, and then I will show you some illustration over here. Add page below, over here. Okay. Remember what we said before. The way you visualize the utility classes is there's only one single box. In this case, counter. In this case, we got 3 attributes over there. We have counter, we have minimum, we have maximum. Counter value initially is 0, minimum 0, maximum 3. That's what we have. Okay? So now, when you are trying to run the JUnit test class, which is test counter, it is going to run the test method one by one. Okay? So now, remember we got two methods there. Let me just show you again. You got test one increments and test decrement from 0. That's what you have, right? You got two methods there. Let me just go back to iPad and I'll explain to you. So we got two test methods. So we're going to say test one increments. We're going to call this first. So this will be the first test case to run. The second test case to run will be test, and then we have decrements from 0. So these are the two test cases. Okay, I'm going to call this in different color. This is number 1, okay, and this is number 2. Okay, so now let's be careful over here. Okay, for test 1 increments there, what do? We try to increment the value from 0 to 1. What it would do is, it's going to change the value of the counter to be 1. Agree? Now, when we reach this test case over here, the counter value that we have is no longer the initial value anymore, because we are talking about this very same instance over here. So the counter value was actually 1 rather than 0. That's why when you are trying to test the utility classes, you should always reset the attribute value to its initial value. That's why. Okay? I'm going to write it down. Okay? And then you may have questions. So when starting each test method, we should reset the attributes to their initial values. To make sure it's a fresh start. This is kind of the special cases because we're talking about utility classes. We got static. Okay? But later on, when we talk about testing non-static, non-utility classes, we don't have such issue. But now, the only thing you got to remember, always reset your attribute values before you start a new test. That's my point. Okay. Any question about why we are having this kind of issue here, right? Because the previous test increment the value from 0 to 1. When you run the second test, you wouldn't start with the fresh value anymore. You will start with what we have accumulated the change so far. Okay, that's my point. Okay, that's something I kind of forgot. That's why I saw the green bar initially, because I didn't do the reset. Okay, please, something to take care about. Any question about this before I go on? Yes. Hmm? Well, that's how JUnit is designed. Basically, what it would do is, depending on how you order your test cases, it's going to run the test one by one. I believe there's some facility for you to actually reset the value to be certain initial value. You know what? Maybe let me talk about resetting this maybe next time. So I can present to you some code. Okay? But this is one way, just resetting it manually. Okay? Okay, I'm going to go back to the code, make some comments, and then we'll go back. Okay? Okay, so now let's go back to Eclipse over here. And then over here, we'll say that it is important to reset the static attributes to their initial value. Okay, that's important. Okay, so now let's go back to the original issue. Okay, so now over here we set the counter value to be its minimum again. That's the initial value. And then we try to use this method here illegally. as Raymond actually just raised, why do we not assert something? It's because there's no such an assertion in JUnits which can assert if some exception occurred. But you do have some mechanism already try and catch. That's something we can do. Okay? So now, over here, if you simply just run it over here, it tells you that there was an illegal argument exception thrown. However, it seems to make sense to you, right? You try to call this method here, and then you throw some certain exception. However, this is a definition for a success for JUnit test method. If you try to run a test method from the beginning until the end, what does it really mean to be a success? It means there's no exception occurred, there's no assertion failure occurred. That means it's success. Okay? In this case, we do have an exception, so that's not a success. So somehow we have to say we catch this particular exception that we expected, and then to make it just run smoothly. Okay? So what do I mean? Okay? I know it's a little bit tricky here, but let me just illustrate on the paper first, and then we'll come back to Eclipse and fix it. Okay, I think over here. Okay, so now let me just frozen. Is it? You're right. In which case, what I should do? Ooh, good. But you know what? Disconnect and connect. Okay, let me do it again. It's back. Great. Fantastic. Good. Okay, good. So now, let's now try to do this one here properly. Remember, we try to also counter dot value is assigned to the minimum, right? To reset. Okay, that's something we added. Okay, now, how do we fix this? I'm going to add some code to it, and let's see how we can fix it. I believe, let me try this. I believe there's a way for me to move this up. Good. Now, what should I add? Basically, this is the idea. We do expect some exception to occur at this point, right? We do. So that means, let me phrase it down a little bit. So let me put an arrow here, and then I'll put a comment here. We do not expect to reach this line. Expect to reach this line. Why? Because after counter the decrements, we expect certain exception to occur, which will break the normal flow of execution. So we don't expect this line to be reached. So what do we expect? So what I would do is like this. I would say try this particular block of code and catch. And I can say illegal argument exception. Okay, I'm just being lazy. I should spell it out on your computer. Okay, some exception here. And now, there's something very important to note. Now, there's two things we gotta add. What should we do over here? And what should we do over here? Okay, the two yellow highlights, what should we do? So now, let me ask you one thing. So this is number one. This is number two. Let's talk about this line over here, counter the decrements. If the illegal argument exception occurs over here, where will we go? We'll go to the catch block. Agree? In that case, that means we do have the exception thrown, in which case it's a success. There's no need to throw any assertion failure. Then we are okay. In this case, that's for number two. For number two, this means precondition violation occur as expected. as expected. So nothing to do. However, in point number 1 over here, if we actually are able to reach the next line, right? If you're able to go from this line over here to this line over here, that means no exception has occurred. In that case, it was not as expected, because you do expect some precondition violation to occur to break the flow and go to the catch, right? And in this case, what should we do? We should throw some assertion failure. Remember, not just assert true, we also learned about fail, right? In this case, what we should do is to say fail. Over here, you would say, no precondition occur as expected. No precondition violation occurred. And then I'm going to write that in the program again, okay, just to strengthen your understanding. Okay, so that's kind of the layout for testing the second category of scenario, where you do expect some exception to occur. Okay, let's just go back to Eclipse and then we look at that quickly. Okay. Okay, let's now go to Eclipse, and now let's see how we can fix that. So now, for the try and catch, so let's say we try and catch this particular line. Okay, so now what we will do is try and catch. We're going to try this line over here, and then we'll catch something. Illegal argument exception. Okay, let's see. Let's put some comments, very neat comments. Executing the method call below, we expect an illegal argument exception to occur. If we are able to reach this line, that means the expected illegal argument exception did not occur. Right? If we are able to bypass this line here and go to the next line, that means it did not occur. Right? It should have gone to the catch block. Okay? If we reach this branch, that means the illegal argument exception occurred from line number, you can see it's line number 29. I'll say line number 29 here. This is expected. So no assertion failure. Okay? Are we good? Okay, that's kind of okay, so now how do we test this? First of all, let's make sure that's really going to test our precondition. Okay? So now if we try that, yeah, let me just fit. Did I do anything? Yes, thank you so much. If we are able to reach this line, that means the expected illegal argument exception did not occur, so we should fail. Thank you so much. Fail. The expected illegal, let's say illegal argument exception did not occur. Okay, like that. Okay, we'll try both cases to really convince you. So now, if you go back to the decrement method over here, just review. If you go back to decrement here, we do have this condition here to throw the illegal argument exception. So this test case should pass. And I will show you why it will pass. That can also help me introduce one more tool. Okay, let's say we try to run this, and then we can say run as JUnit test. Okay, it's a pass. Okay, so far? So now, I'm going to introduce you something new. I only need 5 minutes, okay, to introduce this new thing. So let me write it down first, what this new thing is called. It is called breakpoints and debugger. And it will be very useful for the rest of your class. Okay? It's called breakpoints and debugger. What does it do? Very easy. Slow down your program and execute line by line. That's kind of the principle. Line by line. Okay, that's the principle. I'm going to illustrate to you. It's very easy, but you need some practice. Okay, let me go back to Eclipse over here. So now let me go back to the test case over here, test counter 2. Okay, now you can see on the left, you actually got some blue line over here, blue bar. So now if I click on here, double click, you can see there's a point over here. It's called the breakpoints, which means the next time, if I say I want to debug this program here, it's going to pause the execution over there so that I can execute the program line by line. Why is this useful? Let's say in your lab test, when your lab submissions, somehow you fail a particular test. Nobody is around you. I'm not around. Your friends are not around. Nobody is around. You're on your own. In which case, the best way you can do is to slow down your program and examine the variables to find out the bug yourself. That's what you would do. Okay? That's what I will show you. Okay, first of all, now I'm going to run the program slightly differently. What you should do is, you can see there is a bug button there, right, in Eclipse. It's called debug. Okay? If you click on that over there, so, okay, so first time, you just say yes. Or you can say, remember my decision, doesn't matter. Okay, just say yes. So now it's going to bring us to a different perspective. So now you can see that the program execution stopped over there, right? It stopped actually over here. That's where we set the breakpoints over here. So now I can examine different values over there. So now there are two things I want you to look at, especially this one for now. Go to Window and go to Show View and something called expressions. Okay? So over here, you can write down any expression that will make sense in this context, and it will evaluate for you. So now this is the best thing to debug. Let's say, at this point, I want to know what the initial value is. Counter.value is equal to 1. You will rewatch the video and see why it is not 0. Remember I said before, the previous test incremented the value from 0 to 1. So now we pause at this point. It's right before we try to reset the value. That's why it is still 1. Okay? So now, there are two options for you. Let's just do the, you can see one of them is called step into. That means you want to step into the definition of a particular method. Or there's another one called step over, which means go to the next line. Okay? Let's say we go to the next line. What would you expect the counter.value to change? You should go from 1 to 0, right? So now if I do that, indeed, it goes to 0. Okay? So you can see it's kind of this kind of slow motion. You can see what do I expect to see. If it really happened, I'm okay up to now. Otherwise, you know what to fix. Okay, so now let's see this. If we go to the decrement over here, I want to know if the exception is really thrown. What I can do is I can go into the method. I can say step into rather than step over. If I say step into, it goes into this method right in the beginning. Okay, so now I want to know what the value is, so I can simply say value. Currently it is 0. What about counter dot minimum counter value? It is also 0. 0 equals 0 should be true, right? So if I say step over again, it tells me I will go into this particular branch. You see, without the breakpoints, you wouldn't be able to stop and see why your program is correct. Okay? So now you will see that you really throw the exception and step over again. So now you can see you go to the catch branch, right? You didn't really get to this fail. Okay? One more, give me 2 more minutes and then I'll be done. I want to show you one more case for the debugging. Okay? Let's say I make some mistake in my program over here. Let's go to counter. Let's say I never check the precondition for decrements. I never do that, let's say. So it will not be thrown. I'll just make that into comments. It's intentional. So now I should expect the test case to fail, right? Let's try to debug again. Okay, click on the button there and I'll say yes. So now over here, let me just go to the try and catch block. So I will say step over. Now I'll step into the decrements, which has the wrong implementation. So now if I go there, you can see it will do value minus minus, right? And there's no exception thrown, which means after that, you can see I didn't go to the catch block because the illegal argument exception was not thrown. Instead, I reach the next line. And in this case, I know something has gone wrong. So that's why I failed. In this case, if I step over again, it failed, and I will actually get the red bar for the JUnit test. Okay, that's what's going to happen. Any question about this debugging tool? So let me 30 seconds, and then I'll be done. So I think try to review the video, especially for the breakpoints in Debugger. Okay, and then we'll talk about a new topic on Thursday. Okay, see you.